Okay, so in order to get this one, it would help if you watched the video SOHCAHTOA to XYR. Yeah, it'll just help you figure out what's going on here because I'm going to breeze through this one a little bit quicker. Okay, so find sine 2x, cos 2x, and tan 2x under the given conditions. So, sine x is equal to that for 0 is less than x, which is less than pi by 2. What does that mean? Well, I'll show you. So I'm doing question A right now. Now, what this means is that it is in the first quadrant. It is between 0 and pi by 2. Well, this is pi by 2. So I drew this thing a little bit small. Oh well. So this means that it's 5 over 13, which means that the y value is 5, because remember this is y over r. Watch that first video from question 1. And this says that the r value is 13, and the y value is 5. Doesn't look much like that at all. Try that again. It actually looks like this. 13 and 5. Now, we do a Pythagorean theorem, 13 squared minus 5 squared. Take the square root, and ta-da, you get 12. 12. That is not some magic crap. I did a right angle triangle. I have 13, so 13 squared minus 5 squared is equal to 12 squared. A squared plus b squared equals c squared. If you can't follow that, watch the video for question 1 and maybe go back to grade 8. Oh, okay, anyways. So from here, I get this. Now, from that, I know that the sine of x, well, I already knew the sine of x. The sine of x is equal to 5 over 13. Cos of x is equal to x over r now, so 12 over 13. And the tan of x is equal to, well, tan is O over a, so for this angle in here, it's O over a, or y over x. So 5 over 12. Okay, so I'm going to use those three, and I'm going to find these three things. First of all, sine of 2x. Now, why'd they give you this question? Because first of all, it tests your knowledge on this, and it also tests your knowledge on double angle theorems. Sine 2x is equal to 2 sine x cos x, which equals 2 sine x is 5 over 13 cos x 12 over 13 equals, punch it out, pausing. Perfect. Is 120 over 169. Can't be reduced, so that is my answer. I am done. Okay, so exact same thing. But now I'm going for cos 2x, which is equal to cos squared x minus sine squared x, I believe. Okay, now remember that this squared, I'll just write this up here. Remember that cos squared x is the same thing as cos x all squared. So when that squared is in on cos x, so cos squared x just means cos x squared. So I can turn this into, let's take cos x, so 12 over 13 squared minus sine squared, which is 5 over 13 squared, and then you punch those two through, pausing again, equals 119 over 169. Damn, that is close, off by 1/169th. Anyways, that's not important. What is important is that you plugged into here, you squared it, and then squared this, and then subtracted them. So this went to 144 over 169, this went to 25 over 169, you subtracted and got that. Okay, now, get me some eraser here. I need to get this crap out of the way. Okay, I'm going to do this in pause. Okay, so what I've done is I've written the tan 2x up here, and now that is equal to, sorry, it's getting late. Tan 2x is equal to, now I could do this in one of two ways, either the hard way or the easy way. The hard way is to use the trig identity. The trig identity of tan 2x is 2 tan x over 1 minus tan squared x. But nobody memorizes that, so I'm gonna erase it. What is easy to remember is your quotient identity. If you don't know this, then you are in deep trouble. Tan 2x is equal to sine 2x over cos 2x. Now, since I've solved both of these two suckers, I can just divide them. I get 120 over 169 divided by, okay, I don't have any room here, so I'm just going to do a quick flip multiply. You guys all know that divided by is flip multiply? If you don't, learn your math. So I end up getting the sine, which is this, divided by the cos, which is this, which gives me the tan. So I take that, instead of dividing by this, I flip and multiply by it. So that's supposed to be 169 on top over 119. So I get 120 over 119. Done. And that is the easy way, because once I've already got sine and cos, I can always get tan. Sine divided by cos is tan. Cha-ching!